Hello guys, I hope it started. So, let's see. Does it work? I hope it does. Let me check. I don't want to do it again. Let's see if it works. Yes, it does work. All right, perfect. Hello everyone. So today, you're very lucky to have me here because I just had my driving lesson in fog, which was very scary. And just a heads up, if you are a pedestrian in Cambridge area, just be careful because I'm there on the roads. But I'm back home safely, alhamdulillah. So today we will be doing alkanes. So I have this idea of making a series of live streams with chemical properties of organic compounds for A-level chemistry. So it won't be just everything we need to know about alkanes, for example, yeah, but it would be just chemical properties and the methods to prepare every class of the compound, because what I noticed is that students, they don't really struggle with nomenclature or how the bonds are formed, or anything that is not related to the reactions. Yeah, so reactions and mechanisms are the most important bits which everyone is struggling with. And so what we'll do is in every stream, well, hopefully I will be consistent with that. I'll try my best. So we would study one class at a time. So for example, today I'm going to do alkanes, and for every class we would do chemical properties, right? So how those substances react, and also preparation of the class. This is extremely important to study it in that way, yeah, so not just chemical properties but also how can you prepare certain classes, because once we've done like 5 or 10 classes, you'll say thank you because when you start doing the synthetic pathways, things get complicated. So you need to be able to quickly identify which class you're making, how, from like the interconnection between classes, yeah, so which reactions you could be used to prepare certain compounds from other compounds. So okay, again, as I said, these streams would be tailored for A-level chemistry students. If you're an IB, well, this particular one is fine, yeah, for alkanes, but maybe not the rest, because in IB organic chemistry it's pretty well, pretty easy, to be honest. So let's see. All right, so let's start. So today we're doing alkanes, and I have my notes. Let me gather myself here. Where was I? Okay, alkanes. Again, it's not tailored for any specific board. It's pretty much the same in all A levels. So I'll tell you if some reactions you won't need for some special boards, but mostly it's the same for every board. Right, so let's start alkanes. And oh yes, and an important thing is that the best way for you to go through these streams is to make notes alongside with me. This way you will memorize, and by the end of the lessons you will have nice concise notes, yeah, which you will be able to use when you're solving synthetic pathways. So take your piece of paper, maybe just assign some notebook for that, and let's move on. So let's start, and we start with alkanes. You'll have to bear with my handwriting. I used to use presentations for organic chemistry. I'm not doing this anymore because no one remembers anything if everything is printed. So you have to really write with me to be able to memorize stuff. Okay, so we start with alkanes. The general formula of alkanes is CnH2n plus 2, and that's the only extra thing that I'm going to write. Nothing else. I'm not going to explain what they are, well, maybe briefly, yeah, but just we'll dive into the chemical properties right away. So let's start. Chemical properties. Properties. Okay, first chemical property. I'm not sure how I'm going to structure this, but let's just do it this way. Okay, so first chemical property would be halogenation. So if you have an alkane, it would undergo halogenation. It's a reaction with halogens, for example, Br2Cl2. And for each reaction, you need to memorize conditions and, well, the products, obviously, right? Okay, so let's just write an example. Let's say we have ethane, and you react it with chlorine. This reaction happens in such a way that one or more hydrogens would be substituted with a halogen. So you would form at the first stage C2H5Cl. Yes, so you see I'm substituting H with Cl, and the other H would combine with Cl. So you form C2H5, Cl, and HCl. The conditions for this reaction is that you need UV light. Okay. Then the mechanism. Should we do the mechanism right here? No, let's not even do that. Let's do it this way. Let's write all the chemical properties with all the conditions, and then at the end we would study the mechanism that is relevant for this reaction. Right, remember that during halogenation, you can have more than one hydrogen substituted. So if C2H5 has 6 hydrogens, well, you can substitute anywhere from 1 to 6 depending on how much chlorine you have. Let's substitute, for example, 3. So if you have C2H6 and Cl2 in 1 to 3 ratio, you would form C2H3Cl, right? So Cl3, because I've substituted 3 H's by 3 chlorines, and 3 HCl's would be released. You can substitute more. You can substitute all 6. Let's substitute all 6. Plus, then you need 6 Cl2, right? And you'd form C2Cl6 and 6 HCl. Fine. For all of these reactions, you need UV light. And of course, this is not the best way to get a halogen or alkane. You need some specific one, because the mixture of everything would be formed. Obviously, you would favor the formation of one chloroethane if you use a 1-to-1 ratio of halogen and chlorine, but still some of these are also possible. Yeah, so you get the mixture of products. Okay, that was the first reaction, halogenation. Then the second reaction of alkanes would be cracking. And okay, let's see, do we need 2 types? Yes, I think we need 2 types of cracking. So, well, the cracking, what is it? It's just when you have a long chain alkane, and it would be split randomly into shorter chain alkane. So first we would talk about thermal cracking. I think you can hear my cleaner hoovering, but hopefully not. Thermal cracking. Right, so for thermal cracking, the conditions would be a high pressure, about very high pressure, 7,000 kPa, and high temperature. And thermal cracking would produce mostly alkenes and sometimes hydrogen. So alkenes, shorter alkanes, and hydrogen. Let's write an example. So let's say we have something like C8H18, and you just, so it's a long chain alkane, and you just decompose it to form an alkane and alkene. And again, the chain can break in any, like anywhere. It's more or less a random process. I could form, for example, C6H14, which is an alkane, right? CnH2n plus 2. And then the other one, what would it be? So, okay, so if I have C6H14, I randomly chose this molecule. Then the other molecule must be C2, yeah, because I have to make 8 in total, 8 carbons in total. And then H would be what, 4, yeah? And that's balanced, that's random. You could do something else. Yeah, you could write the same reaction in another way. So you could form, for example, C5H12, and then you'd form C3H6 H6. That's an alkene, right? So you form an alkane and an alkene and sometimes hydrogen. Conditions for thermal cracking. Let's write conditions: high temperature and high pressure. High pressure. Next one is catalytic cracking. Catalytic cracking. So in catalytic cracking, we would mostly produce branched and cyclic alkanes, yeah, and aromatic hydrocarbons. Okay, branched and cyclic. So here, you can write, yeah, if you want, you could write that here the most common products are shorter alkanes and alkenes. Here we would say that it's branched and cyclic. Yeah, so alkanes and alkenes, shorter chain are formed, and hydrogen. Yes, so and sometimes hydrogen. Here branched and cyclic alkanes. Cyclic. Taking notes, of course, it takes longer than just showing you the presentation, but I just know you won't memorize if you just look at my slides. Okay, so let's do it this way. Please write. Don't just listen. Okay. Well, and okay, we can take an example. Yes. Okay, I'll tell you the conditions later. Obviously, you guessed we have to use a catalyst. Well, let's say we have something like, again, maybe C12. Let's take something longer. C12H for an alkane, it would be CnH2n plus 2, so 12 times 2 plus 2, 26. And we can form something cyclic and branched. Yeah, for example, we could form cyclohexane. Let's do that. Yeah, cyclohexane, it's what? It's C6H12. Well, and then we would form C6H14. That's an alkane. Could be branched, could be straight chain. Doesn't matter. Of course, you're favoring the branched one. Yeah. Is it balanced? 12 carbons and 26 hydrogens. Yes, pretty much balanced. Now conditions. Conditions for this would be, okay, so we would use slight or moderate pressure, so we don't need crazy pressures like before. High temperature and zeolites as catalyst. That's just one example. Yeah, these examples are actually from AQA chemistry. So moderate pressure. Pressure, a high temperature of, for example, for 50 Celsius, around that. And zeolites catalyst. Zeolite catalyst. Sometimes you would also see steam cracking, but I think if you know these two, it's fine. Yeah, so in steam cracking, you will also use steam so that the chain is broken easier. All right, that was cracking. Next chemical property would be complete combustion. Number 3. Complete combustion. During complete combustion, we are forming, guess what? CO2 and H2O. This is everyone's favorite property because it's the same for all classes of organic compounds. So just take an alkane, let's say C4H10, add oxygen. Combustion is the reaction with oxygen, and you heat it, right? So you get CO2 and H2O. And when you balance these equations, balance in order of CH and then O. So first you balance carbon. You have 4 carbons on the left, so I put a 4 here. Then hydrogens, I have 10. So I put a 5 to make it 5 times 2, 10. And then I balance oxygen. So I have 2 on this side, and on this side it's 8 plus 5, so it's what? 13. 13, well, not the best number, right? So you have to divide it by 2. If you divide it by 2, you get 13 over 2. You could leave it like that. That's fine. Or you can say that it is 6.5. If you hate fractions, you just double all the coefficients. So it's the same as saying 2C4H10 plus 13O2 goes into 8 CO2 and 10 H2O. Yes, so that's 8 carbons, 20 hydrogens, yes, and 26 oxygens here, and then 16 plus 10, 16 plus 10, 26. That's balanced. Next one is incomplete combustion. Incomplete combustion. During incomplete combustion, you get, well, what is it? It's when you don't have enough oxygen. So you would get either CO or not carbon monoxide. CO is carbon monoxide, right? So you get either CO or carbon and water. So you never get hydrogen. That's the most important part. So you always get water and CO or carbon. Well, let's do that for C4H10. It's incomplete combustion. Let's form CO first. Carbon monoxide, toxic gas, remember, binds to hemoglobin, blocks transportation of oxygen because forms dative bond with iron. You know that, all of that. But we are focusing now on chemical properties so that you have a nice list, right? Okay, so 4, and then hydrogen, I put a 5, and again it's uneven. Okay, so then oxygen, 4 plus 5 is 9, so I put 9 over 2, 4.5. And then I'll just leave it at that. So let's check. 4, 4, 10 hydrogens, 10 hydrogens, oxygens 9, 4 plus 5 is 9. Good. Now if I make, let's make carbon. So if you have even less oxygen, it forms carbon and water. So balancing carbon, balancing. This was the worst example possible with butane, right? I always get fractions. Well, and now it's 5 over 2. Okay. Or double all the coefficients if you can't stand those fractions. Fine. That's in complete combustion. Okay, so these were all, let me check, all the chemical properties that you needed to know. Of course, you do need to know how to use fractional distillation to separate them into fractions. You have to know how to explain physical properties. Yeah, that boiling point gets higher as, for example, carbon chain length increases. You do need all that for the exam, but no one has problems with those topics. Yes, everyone just forgets chemical properties, so that's why you need to have them separately. Okay, these were chemical properties. Now let's see the preparation. Yeah, so now preparation of alkanes. How did, okay, I highlight them. So preparation of alkanes. Okay, first method to prepare alkanes is hydrogenation of alkenes. So you add hydrogen to alkenes. Of alkene, so you have an alkene, let's say CH2 double bond CH2 and ethene, and you add hydrogen, and this reaction goes at unit conditions, temperature, pressure, and nickel catalyst or platinum, and you get an alkane CH3 CH3. Yeah, so you just break the double bond, make it single, and add hydrogens. Conditions, temperature, pressure. Let's just maybe shorten it. Yeah, I did it like that anyways there. Okay, so temperature, pressure, not necessarily, but a bit higher than normal is they usually use, and then a catalyst, a nickel catalyst or platinum catalyst or palladium catalyst. Hydrogenation. Okay, that's the first way to form alkanes. Another way, again using cracking, right? Because during cracking we are producing new alkanes. For example, from C8H18 we produced an alkane which was C6H14. So I would still write down the cracking so that when you see your synthetic route and you see that you need to prepare an alkane from something, well, you know where to look, right? You will look at preparation of alkanes. I will just write one type of cracking because obviously you don't care at this point which one, if you know what you need to make, right? So if they don't ask you specifically about some specific cracking, but you just know that you need to form something from a long chain alkane. Well, let's take, for example, let's just take some longer one, and let's write several products maybe. Yeah, so let's take C15H32, and let's just use thermal cracking. Conditions, let's say high temperature and high pressure, and I'll break the chain somewhere. Let's make, for example, C6H14, and then let's make C3H6, random stuff, right? So this is an alkane. How do you know that it's an alkane? You know it because it's that's an ugly N. You know this because it obeys the formula CnH2n plus 2. This is an alkene because it's CnH2n. And then what would the other one be? If we just form one more, then okay, I'll use my calculator. So carbons, I need 15 minus 6 minus 3. That's 6 carbons. And oh, do I get again okay, let's see if I get C6H14 again. So 32 minus 14 minus 6, no, 12. Now it's an alkene. Well, my math is not so good. My mental math is not very good. I'm using technology to figure this out, yeah, in the calculator. But you don't have to if you can see that. the products right away, it's fine. Let's just double check so that it's balanced. Yeah, just double checking. So 6 plus 3 plus 6 is 15, 32 hydrogens, and then 20, 32. Looks balanced to me. Okay, that was the last way to form alkanes. Yeah. Next, let's also include mechanisms here. Yes, so for alkanes, remember we had this reaction. The first reaction was halogenation, and we need to know that this reaction is free radical substitution. You don't need to know the mechanism for cracking or for combustion, apparently, but you only need to know the mechanism of free radical substitution in the class of alkanes. So for every class, we would also write down the typical mechanism, yeah, that you need to memorize. We'd have around like maybe 10 mechanisms, or yeah, I'd say 10, roughly, maybe less, maybe more. And maybe I'll make a note that this is free radical substitution. I would denote them like this. So S is substitution, R means radical. So free radical substitution. And let's write it down. And in the question, like if you're just starting organic chemistry, it might be a little difficult to understand what exactly is it they want in the questions. So sometimes they would just ask you to write a reaction, then you write it how we wrote, yeah? So you state the conditions, you write the reactants, you write the products. But then sometimes they would ask to write the mechanism. So if you see that word mechanism, well, it means that you need to show where electrons are going, yeah? So where pairs are going. And it takes some time to get used to the mechanisms, but you will eventually. Yeah. So after we've done, usually after nucleophilic substitution, everyone gets it. It doesn't require memorization, not even like muscle memory. You need to draw them several times to figure it out. This particular one, free radical substitution, is pretty easy. It's in stages. We don't need any arrows and stuff. But for alkenes and for halogen alkanes, it might be a little trickier, but we will figure it out. Okay, so for alkanes, the mechanism that we need to study is free radical substitution. It's when an alkane reacts with a halogen. So, okay, so free radical substitution mechanism. You should be writing. No way for me to check, but you should be. Okay, free radical substitution mechanism, and let's say we will write it for a reaction of, some people are just leaving when I say you should be writing. Right, so let's write it for this reaction, CH4, and Cl2 goes into CH3Cl and HCl. So we can write it for this one, and then I'll show one more example. Maybe I will, maybe I won't. Let's see how much time it would take. Okay. Right, so this is just a reaction, and now we will be writing the mechanism. So we want to show how exactly these products are formed and what side products we would have as well. So first step in the free radical substitution reaction is called initiation. In initiation, you take your halogen, the molecule of halogen, in this case it's Cl2, and in the presence of UV light, it would form two free radicals, two Cl radicals, yeah? What is a radical? A radical, it's a species with an unpaired electron. It's essentially just chlorine atoms, yeah? So the UV light would break the Cl-Cl bond and form two chlorine radicals. Next step would be, well, and by the way, this is a homolytic bond fission, because let me just show you what happens. So if you think about your chlorine molecule, yeah, that's the valence electrons. Well, during free radical substitution, this bond, it's broken down evenly, so like this, right? So each chlorine gets one electron from the bonding pair. So you get chlorine with 7 dots and chlorine with 7 crosses. And these are your free radicals because the 7th electron, it's unpaired. Okay, that's homolytic bond fission as opposed to heterolytic, but it's fine. You don't need to know it to write down the mechanism correctly. So initiation, we split the halogen into two radicals. Then the next step is propagation. In propagation, what do? We take our free radical that was formed and react it with whatever molecule of you have, yeah, so with a molecule of alkane, so with CH4. And chlorine radical, it would take away hydrogen with its electron. So you would form HCl and CH3 radical. Okay, I'll explain this in a bit more detail. So, okay, let's do it this way. So I will draw the chlorine out. You don't have to draw it, okay? Let me just explain quickly. So, and then you have, well, let's do methane like this. The crosses would be for carbon, for example, the circles for hydrogen. So what this chlorine would do, it would take this hydrogen, I was supposed to color code. You see, it takes this hydrogen, and what does it form? HCl. Yes, so you form H, oh no, oh my gosh, that's supposed to be Cl. Cl and H, yes, so you form HCl, and this thing, you see it's a free radical now because it has an unpaired electron. And you form CH3 radical, so that's why it's a radical. I mean, you don't have to draw it like this in the exam. This is enough. Everyone understands what's happening. Just make sure that you do understand what is happening. If you write it like this, examiners will be okay, that's fine. But then just to make sure that you get the point, yeah? So that's what's happening. So chlorine radical, it has 7 electrons. So it takes away hydrogen with its electron from CH4. And the CH3 is left, yes, CH3 is left as a free radical because of this electron. There it is. Okay, well, I remove it because you don't really need it, just for the understanding. Right. So we reacted chlorine radical with CH4, formed HCl and CH3 radical. Next, you take that radical that was formed here. And also, strictly speaking, guys, you saw that the radical is on carbon, yeah? I don't know why, but no one cares where you write this dot out. I would honestly always write it on the carbon, but in the mark schemes, it's everywhere. So just maybe check your mark scheme, your board specifically. So strictly speaking, it has to be on the carbon, yeah? But normally they don't care. And just, it flows better when you write it on the right side. At least I like it better on the right, but it should be on the left, yeah, if you are very strict. Right, so okay, so you take that CH3 radical, and then what? And then you react it with another molecule of chlorine. And you form CH3Cl, and you regenerate the Cl radical. You see, you formed it again. So Cl radical in this case behaves as a catalyst because you see you consumed it in one step and then immediately it was regenerated. And what does it mean? It means that one Cl radical can break apart a lot of, well, not break apart, it can react with many CH4 molecules, right? So it can trigger the reaction of many CH4 molecules with chlorine. So you don't really need a lot of radicals. You can just use some, and then they would propagate the chain. Fine. And finally, termination step. In termination step, we are just colliding all radicals in randomly. Yeah? So we have Cl radicals which can collide and form Cl2. We have Cl radical that can collide with CH3 radical. And we can collide two CH3 radicals together to form a C2H8. Not 8, 6. My perfect mental math. Today it's even more perfect than usually it is. Okay, so C2H6. And what do you see? You see ethane. Do you find it weird? Well, I do. Yeah, because what do you react? You react methane and chlorine, and you get ethane as one of the side products. And this ethane, it can only form if the reaction goes via the free radicals. Yeah, so if you have two CH3 radicals somewhere there. So the formation of ethane is actually the proof that the reaction is undergoing using the free radical substitution mechanism. Okay. That's it. I hope that's fine. Well, let's see how much time. It is 30 minutes, so I think I have to wrap it up. Just let me know if I should continue with these series, almost like Netflix series for other classes. Yeah, so I plan to do alkenes next. So if you find it helpful, just let me know. If not, so if you'd rather do like exam style questions, please do let me know. Yeah, because I'm not sure. I mean, I think I'm just what I'm doing now is I'm doing the same as how I teach my students at the lessons, but then because YouTube is new to me, yeah, so I'm not sure how diverse the audience is and if it's even helpful. So if I'm going the wrong direction, just let me know. If it's helpful, then we will continue. But of course, again, these videos are tailored for A-level students, right? Not IB or definitely not GCSE. Okay, guys. So I'll see you next time. Next time, I think I'll do the IB stream and after that, another A level. So I'll try it once a week. Take care and careful on the roads. Where's my stop button? There it is.